Here we have a relatively tame looking function, which still has a singularity at the origin. And the question is, can you apply the rules that we've derived to calculate residues to find the residue at the origin here? So it should be pretty straightforward, but still pause the video and work this out. Right, so the function that we have, we can factor the denominator so that the singularities become more apparent. So this is 1 over z times z plus 1. So it's pretty obvious that this has two poles, one at the origin and one at -1. And we happen to be interested in the singularity at the origin. So one of the recipes that we've introduced in the course text is simply taking the function that we're interested in. So this is 1 over z minus z plus 1. Multiply that by z minus the point at which we calculate the singularity. So this is z minus 0 in this case. And then evaluating that in the limit of the point we're interested in, the origin. So this becomes 1 over z plus 1 in the origin. So that's 1. Actually, there's a different way to calculate the residue, something that we've also seen slightly easier in some cases, which is to calculate the numerator. That's again 1. And then calculate the derivative of the denominator. So if we again expand the denominator, like so, and then we take the derivative and we evaluate that in the origin, we have 1 over, this becomes 1 plus 2z. And if we evaluate that in the origin, we also have 1, which is good news. It's the same result. The nice thing about the second formula is that you don't need to explicitly factor out the denominator here like we did in this case. Okay, it was relatively straightforward here, but for some other functions that might not be the case. So here, by just taking the derivative, it's rather straightforward to end up with the correct result.